We'll start the session.
Okay. Let me share my screen. Okay. Last week we discussed about fine tuning mainly, and we continued the session on natural language processing. And also we talk about a new model called OpenBio LLM. That is an open source model. So I have shown how to use a model like OpenBio LLM, and how we can use our own data and fine tune that type of model, which is already pre-trained. So that is all about fine tuning. So today also I am going to talk about a similar concept to fine tuning. That is RAG. RAG means retrieval augmented generation. So when we talk about fine tuning, uh, we were able to train a pre-trained model using our own data. So that's about training. So in here, RAG means we are not going to do it in that way, but we can enhance the responses of a large language model using our own data, using our data sources. So that will be done in a different way. So in order to show how we are going to do that, I am going to use a tool called Diffie. So I'll later come to that tool. Before that, let me explain a little bit about what is RAG. So as its name explains, retrieval augmented generation. So that also about generating a content. So we know, so we are talking about large language models like ChatGPT, Claude. There are many other large language models. So when we are using those models, we can generate a content, but we are using that model without giving our own data. So here we are going to use our data sources. I'll explain why we want to do that. Okay. Let's quickly go through this slide, which explains the difference between fine-tuning and retrieval augmented generation. So mainly fine-tuning trains the large language models on new data. In RAG, we keep the large language model fixed, but we can feed our own data externally. Right? So one of the use cases embedding domain specific knowledge into the model. So we can do that using fine tuning. So in here also, in RAG systems also, we can let the model to access the external data. So most of the time we will use RAG method on frequently updated knowledge, like the data we use on research and related to some medical data and news, especially like that, there are certain data, those are frequently updated. So, this RAG method is well suited for those type of data. In developing the application which uses those type of data. And okay, the data type requires labeling most of the time in fine tuning, and in RAG systems, we use unstructured data like PDF files, data from websites, and all. Yeah. Updating method requires always training when we talk about fine tuning. But in RAG systems, we just have to update the knowledge base. We can create the knowledge base and we can update. Like if we maintain a certain type of data in PDF files, so we just have to update our knowledge base by adding those files to the knowledge base, for example. This fine tuning, as you know, very expensive because you need more resources when you want to train those models again. So, and also time consuming, it takes a lot of time. Last week, during my demonstration, you saw that it needs a lot of resources and also a lot of timing. So that's why I used already executed one as an example. So in RAG systems, it is cheaper because it is fast. We can just upload the files, um, or use whatever the data sources quick in fast way. Okay, in here, in fine tuning, we create a variant of a new model, something like that. But in RAG, we use the base model plus retriever. I'll come to that. I'll explain what is retriever. Okay, this is best for repetitive tasks, highly structured outputs and specific, because when we train a model, we need a kind of structured format. So in here, that is not the case in RAG systems. Okay, how RAG works. So there are three parts: retrieval, augmented generation. So retrieval, in the sense, the system fetches relevant information from a knowledge base. So I'll show you what type of knowledge base it is. So it might contain document, databases, website, um, and augmentation. So these retrieved information will be passed to the large language model that we are using for the application that we are building. So that means, uh, let's say there is a system prompt. So in that prompt, we have to inject our data to that prompt, and then um, uh, we have to send it to large language model in order to process. So uh, during the example that I'm going to demonstrate, I'll show you uh, how it works. I'll show you a prompt. So in that way, we have to we have to inject this, we will do this augmentation through by injecting our data to large language model that we are using. So, and then the generation, then the large language model we are using, then will generate a response using both its internal knowledge and the retrieved information. So it will use both. The benefit is, so we don't have to depend on the data provided by a large language model. For example, uh, there are problems when you are using ChatGPT to get an answer which is related to medical domain, because it is not trained on medical data. So um, we might sometimes we might not get the correct answer. So there can be hallucinations also. So we can keep our own data very specifically to the particular domain that we want to generate the content, so that we don't have to, we can overcome that issue. And also the large language models, the available, almost all the large language models are not up to date. So I'll show that also, why I um, specifying that it is not up to date. I'll come to that later. And let me explain how RAG works step by step. So it extract and store document content like the formats like PDF and CSV files, and then it convert to embeddings like it keep these data in the database like a vector database like Pinecone. So in that case, it will convert it to embeddings. Um, and then retrieve based on a query using semantic search. So you know what semantic search. So um, it will search. It will not only search by keywords. So it will do a semantic search as well. So that is why we want to keep it in a vector database like that. And the fourth step is it will be injected. Mm, it will inject the retrieved content into large language models prompt for generation. So I'll show that. Okay, why we want to use RAG? So as I told you before, there can be hallucinations when we are directly using large language models like ChatGPT or other models directly. So and also those are not up to date. I think ChatGPT is having have trained on 2023, the latest. So if we consider that cutoff date of those models, for example, ChatGPT, the latest point of time up to which the model was trained on data is 2023, as I remember. So that means those are not up to date. And also, we cannot use private data. So in the example that I'm going to show you today, uh, that is I'll use Diffie. So the tool Diffie, we can deploy locally as well. And also we can securely use that tool to build our applications. And we can keep our data private. So if we are deploying it in cloud, we can't say it is private, but there are ways that we can locally deploy the model also. And anyway, we are not sending this data to ChatGPT like the previous examples that I have shown in previous sessions. So we are going to use this method in little bit different way. So, okay, these problems, the RAG solves these problems by grounding the model's response in accurate, real-time, and domain-specific content. So, one of the example use case is customer support chatbots that access product manuals or internal FAQs. So there can be like this example, there can be private data in companies and also related to medical uh, context. So those data is private and will sometimes those data will be specific to that particular domain or that context. So we can create chatbots to access those data in this way. And in the medical domain, medical question and answering systems, uh, those systems which can get data from scientific papers or some other way by feeding some PDF documents or whatever. So we can create these kind of applications. And also enterprise AI assistants that use internal company documents. So those are also private data, specific data. So you can do that. So the tool that I'm going to show you today, that is also very good for enterprise application uh, development and deployment. So that's why I have chosen that tool other than just using a tool which can be used in research purpose. Okay, the key components, as I explained before, key components in a RAG system are retriever, large language model, and the knowledge base. So what is this retriever? So that is the that is a vector database like Pinecone. So for example, yeah, we can say it's a vector database. So the data will be retrieved. So data will be stored there and will retrieve from the database like that. And then large language model like ChatGPT and the knowledge base. So your documents will be should be there, and we can use those documents. We'll store those data in the database and then we'll retrieve and we'll feed to the large language model in order to generate the output more accurately. Okay, then retrieve relevant information and augment prompt and then generate. The response from the large language model will be generated uh, using this augmented prompt. So it is not just a prompt like we have used before. So this retrieved information will be injected to that prompt. That is the difference. So what is a vector database? So database is a type of database which is optimized for storing, indexing, search high dimensional vectors, and is a numerical representation of data like Solution explained before. So this also, like if you consider the sentence like high blood pressure, it might become numbers like this. So there is something like that just to get an idea about vector databases. And you might think why we are going to use vector database without using relational databases. So we are going to get the semantic search also done in this way. So we cannot achieve these things by using relational databases. You know, there are relational databases like SQL Server, MySQL, like there are very structured relational databases. So for this purpose, we are going to use vector database. That is the most suitable way in implementing RAG systems. Okay. Okay. Let me demonstrate. Okay. Let me first of all show you this tool, Diffy. So some people call it Diffy. Some people call it Diffy. So if you go to this URL, so if you want any assistant in setting up your applications in Diffy, you can talk to Mr. Sanjaya or Sampath because they have already set up their servers. So if you after this demonstration, I'll show you how you can create your own applications, a very simple application. And then you can try it out by using there is a free version also available. So you can try it out and if you want to investigate more on it, you can talk to them. They will set up an environment for you to work with. Okay. Here, go to this URL. Then you will so you can find many tutorials related to Diffie in YouTube. So you can learn more. This is a very simple application. I am using this tool to demonstrate what is RAG. Uh, so the this tool is not for the only purpose of implementing RAG applications. So this is a AI platform that you can use to build AI agents, any other type of AI applications as well. So, but I use Diffie as it is a great platform for starting large language model developments. So like workflows, agents, chat flows. So you have seen, I have shown you another tool called N8N. That is also a similar tool, but the purpose is different. Uh, so Diffie you can use for many purposes. This is uh, the purpose is different. So you can try Diffie to implement RAG. You can also use N8N for that purpose. And uh, there are differences. As I told you before, you can use the tool Diffie for enterprise level applications as well. So like that, and also without less minimum development knowledge, you can use this. This is a no-code platform. So there are uh, benefits like that. So when you want to log into Diffie, you have to go to that URL and you have to sign in using your Gmail credentials like this. Yeah. Okay. So you will see there are these menus. There is knowledge. So as I told you about REG, this is the most important part, knowledge. So RAG is inbuilt to this knowledge module in Diffie. So we are not going to do much work in order to create a RAG application in Diffie. That is the other reason that I have selected this tool. But if you are using another tool, probably you might have to do some more work in order to create application like that. But when you are creating a knowledge base, uh, it it will do that using vector databases and all in the backend. So we don't have to do much work. We don't have to write any coding for that. You just have to upload the knowledge base to this tool. Okay, so I have already created application. Once logged in, you can go to Studio tab. So when you go to Studio, you have an empty page, but I have created three applications. That's why I can see there are three nodes here. Okay, I'll go to medical chat flow and show it to you what I have done. So if you remember in 810, you might um, already know that we can create nodes like this and create a workflow. This is also a little bit familiar thing for you, but let me explain it. Okay, here what I have done is I have created a chat flow. So there is a start node. It's just it will automatically come when you are creating the application. So then I have added a knowledge retrieval module. So this is actually a block. So I have created knowledge retrieval block. So in the knowledge retrieval block, in the right side, it shows this file. So this file, 15 natural ways, this one, I have already created a knowledge base using this. So I got this data, 15 natural ways to reduce migraine symptoms. So this, using this article, I created a PDF file and I added it to my knowledge base, right? So that's why in the knowledge base, it is shown. So this is my file. This is my PDF file. So the status shows as green available because I have correctly added my knowledge base. That is about knowledge base. So part of RAG I have already implemented in that way. Then go to Studio. In the Studio, I have already created this application, medical chat flow. In the medical chat flow, in the knowledge base, I have added this knowledge base. And also I have added a large language model to it. So in the large language model, I have added my model, ChatGPT model. There are various models of ChatGPT, OpenAI models. So I have added this one. Okay, and also I have given a system prompt like this. I have added this one. You are a professional and reliable medical assistant, AI, designed to support users in understanding medical concepts, symptom, symptoms, diagnosis, and treatment options. Your role is to provide educational and supportive medical information. Use the information provided in the context variable. And I have added the context also. So here I have added a context. Knowledge retrieval context shows as result. So that is my context. I told you this LLM, we will provide the knowledge that we have added as a part of the prompt to the LLM. So this is my system prompt. When I click on LLM, that is my large language model here. So when you click on that node, it shows the system prompt. So in this system prompt, I have injected this context variable. So this shows the output of this knowledge retrieval block. So that is my knowledge base. So that will be not the entire knowledge base. It will extract the important parts of the knowledge base and that will be injected to large language model. And in that way, we will inject our knowledge base also to large language model. And then the output. So large language model will give the output as the answer, right? So then you might understand now what is the difference of using large language model itself and using a RAG system. So in the RAG method, we will provide the knowledge base and feed it into LLM. Then the output will be different. Okay, let me quickly execute this one. Let me show you my PDF first. Okay, this is my PDF that I have created. That is available in my knowledge base. In the preview, yeah, in the preview, I didn't publish it yet. If you publish it, you can share that URL with others also. It will be available public, and they also can use this chatbot. So in here, I will now give a prompt. Um, okay. Natural methods. So it will give the priority to this your own knowledge base other than going to provide an output from large language models. So most of the time, these two are combined. Like, for example, if I ask a totally different question, it might not be able to answer because it is not available in my knowledge base. So in that case, large language model provide an answer. Like the same way, if we ask a question from ChatGPT, it is giving an answer like that. So those two together will provide an answer for you, but will be given the priority to this one, your own knowledge base. So this output is based on the knowledge base that we have added. It says this is the citation, and it gave a final note as well. So so you can give any prompt here. So this is just example. And okay. All right. So let me quickly show you how you can uh, create this type of application. Before that, let me show you this is also like N8N. There are a lot of tools available in this Diffie. So you saw there were Google tools, and there were a lot other tools in N8N. Here also you have these type of tools that you can use when you are building your applications. Okay, and also in addition to that, there are templates which are already created. If you want, you can, here I have created these projects, these applications using create from blank. So if you want to use a template um, which you can use with less effort, then you can go to create from template and choose a template and create. Here there is a drop down. There are chatbots, there are agents which are already created based on a template. So you can use these templates as well. Then if there are templates which is suitable for your problem, so then you can apply those template and do modifications and create your application. Here also there is a filter that to filter what type of template you need. So those are the main features available in Diffie. But I'm giving the focus to this knowledge base and RAG application. Okay, here I have now logged into Diffie. I have logged in from a different Gmail account. That's why there is nothing in my studio. So, and there is no knowledge base. So if you are going to create your own application, follow these steps. So you can create from blank. So select the first option, create from blank, and select a chat flow. If you want to create a chat flow to try out RAG, then give a name. Net flow, and you can select another icon, create. Okay. When you create a chat flow, all the nodes were added already, but you don't have a knowledge base. So you have to click on this plus button and add a knowledge retrieval. So from here, you have to add the knowledge base by clicking on this plus button, but there is no knowledge found. So you have to create it. So you have to go to knowledge tab and create a knowledge base. Create knowledge base. Click on create knowledge base. And from there, you can browse a knowledge base. Um, Okay, I'll upload the same document that I have uploaded. Okay. Then upload. So when uploading, you can specify some of the parameters. So I'm going to proceed without changing anything. Save process. And the knowledge is created. Go to document. So now the knowledge base is added. Right? Okay. And then go to Studio again. You have your app here. So when you go to knowledge, you can add your knowledge base now by clicking on this plus button on your right side. So this document has come because there's only one document. It is there. So I'm going to add that one. I don't know why it is. Okay. Now it is added. So under knowledge, you have your knowledge base. Okay. So the next thing to do is specify the output variable. So output variable, you don't have to specify. It is there. The output variable is result. Okay. Go to large language model. Model is not there. Shows an exclamation mark. So you have to set up the model. So in order to set up the model, go to top right corner. There is this profile icon. Click on that. There is this settings menu. Go to settings and go to model provider. Okay. When you go to model provider, this OpenAI is there, but you have to click on install button in order to get it added. Okay. Okay. It says it has not been fully configured yet. Even though I have added this one, it complains. Let me choose a model. Oh. The problem is still the error is there because API key, you have to provide the API key for your, as you are going to use OpenAI. So to provide the API key, you have to go to OpenAI platform. I have shown this before. If you want to get API key generated, you have to go to this link and create a API key. So when you go to that link, it will show you the OpenAI site. So from there, go to you are already there. So the link I have provided, if you click on that link, you can go to API keys. If you can't access it directly, then you have to log into OpenAI website. The same way we are logging to other sites, you can just provide the credentials. I think from Gmail credentials, you can log into OpenAI platform. So go there and find this link for API keys. From there, you can generate a API key. Create new secret key. So click on this button and create a key. Meta oh, like this. Just give a name and then create a secret key. And then copy that key. I'll keep that key, copy of the key here also, just for a backup purpose. Okay, copy the key and go there into your DeFi site and then setup. In here, you can add your key. And click on save button. Okay, now the green icon appears. That means the API key is okay. Okay, now you can go back to your app. Okay, there was another warning because I have not set the model. So okay, now I have set up the model. Okay, you can change these parameters as well if you need. Okay, anyway, I have added GPT-4. Right. From here, I am going to use mini version because this is just for a demonstration purpose. So I'll use mini. Right. There's no, if you want, you can use a better model. Right. Now, okay, now I'm done with this. But there's only one problem. As I told you before, from the knowledge retrieval, the output of this one will be the input, will be an input to large language model, because I am going to create the prompt for large language model by adding this, the output of this knowledge retrieval. So go to LLM, click on the LLM node and give a system prompt. So I created a system prompt like this. You don't have to give such a long one, but I have added this prompt as I shown uh, previously. Uh, the system, in the system prompt, I have included that the same way we are giving prompts. You are a professional and reliable medical assistant AI designed to support users in understanding medical concepts, something like that. So this is the prompt, system prompt. But here I am going to include my context variable as well. This is the output of this is the knowledge base. So I'll copy this one and paste it here. Uh, I'll show you how can I add. Here I have put use the information provided in the context variable, and now I want to specify what is the context variable here. So provided in the context variable to enhance your responses with accurate and relevant medical knowledge. So this is like I am asking large language model to not to use his own output, but use the input given by me, that is my from my knowledge base, and enhance your responses with accurate and relevant medical knowledge. Ensure that your answers are basically something like this. Okay, so here I'll put curly braces. So I'll show you how to add that type of variable. So put the curly braces, and then it will show all the variables available. So here there is the context uh, variable, and you can add that. There might be some other ways to add it, but this is how it worked for me. So okay, and you are done with your prompt now. So you took the LLM block now configured with this context variable, right? Now, from the knowledge base, if I look at the output variable, because this output is the input for the other block. So output variable is this one, result block. So that is the context variable. I think you can specify it as result within curly braces. So I didn't try it out. Okay. Right. Now I'm done with this one. So I can go to preview and try it out. Um, um, it shows with the highlighting with the green border. That means this node, right now, this node is being executed. And now it came to LLM node. It is processing the LLM node. Now it's given the output. Okay, it works like that. So I just wanted to show you how RAG works and how you can implement RAG systems. So this is a very easy in Diffie. So you can try out other tools as well. The last time I have shown you N810. Using that tool also you can do the same thing. So there are other agentic applications as well you can try out. But this one, I recommend you to try out this one as well. Okay. I have another example to show you. That is, we have another 10 minutes, so I'll quickly show that as well. Let me go back to um, the example that I have already done. This is a chat flow. So if you want to create a workflow that can be automated, then you can create that as well. Here I have already created an example. So here what I have done is I have added this node. So it is a search node. So I have used the tool called Brave Search. If you click on this plus button here at the bottom, you will see all the blocks that you can add. So blocks are, it can be a LLM block or a agent block, knowledge retrieval block, and also if then else statements like here it is going like in a linear way. So there are no complexities, but when there are complex workflows, you have to put nodes and you have to give some conditions. Based on certain conditions, you can put a if statement and check a particular condition and forward to another path, something like that. So there are if else statement for that purpose, and there are a lot of blocks that you can add. In addition to that, it will show tools in the other tab. So in the tools, it will show only few of the tools. But if you go to find more in marketplace, you can find more tools. Uh, so it doesn't mean that you have to pay for all these tools. So it's just you will find those tools in the marketplace. So from these tools, actually, I have used this Brave search tool. So Brave search is also like a search tool like Google search engine. It's a privacy focused search, and also it provide AI answers. So you can you can compare about these search tools if you are going to create an agent for using uh, for searching the information on the web. Then you can use a search tool like this. uh, so here you might have seen this browser Brave. I don't know whether you have used it before. There is a browser like Chrome and Firefox. This browser, some people are using this Brave browser. So the owner of this Brave browser uh, is the same one who owns Brave tool. So uh, in this browser, there are no ads. Like it's a more secure search engine. In you when if you want to use Brave tool, you can click on this tool. Let me search it from here. Then I can show it to you. When you go to tools, the Brave search is not available there. So when you go to marketplace, it's there. Okay, you can search, type Brave search it, then you can edit. So you can same way you can install it. There is this install button. So you can install the Brave search. Okay, now it's added. So when you go back here, you can see the Brave is added here. So click on that. Then you can add a Brave search to your space. So that way you can add the Brave search. I have just shown you how to add it. Uh, Let me first execute this one because you already know how to add other blocks. So if you want to add Brave search or whatever the tool that you want to add, you can do it in that way by clicking on this plus button. You can search tools. Right. In here, what I have done is I have when the block is added, click on that. Then you have to give a input variable for that. So this is a search. I have created this app to search uh, in the web on uh, certain, let's say in here I have added some health related web URLs. So by adding those URLs, I am asking the large language model to summarize these information for me. So I have added this search tool and this URL, this URL. So earlier I got these details to a PDF file and I uploaded PDF, but in now I have got this URL copied and then I have added it to here. And then I told the result count as 3. So give me 3 results by going through this document. The output variables can be a text, files, or a JSON format, but I don't have to do anything there. I just have to give the search URL. And then I'll go to click on LLM and I have already set up the model and all, so those are already added. I have to do nothing there. And here, when you click on LLM, see the context. So I explain about what are the context variables. So if you click on context, you will see these context, text, files, and JSON. So I'll select text because this tool will extract the texts from the web URL that I have been given. So then I have specified the text here. And then I gave a simple system prompt like use the Brave Search tool to search and summarize the search result you received from the context variable through the context variable. It shouldn't be like that. So you can add whatever the prompt you want, but there should be it should be meaningful. Like it should be able to do what you want. So depending on your problem, you have to give the prompt. So creating the prompt, you can get the support from ChatGPT or any other large language model. Okay, I have given the system prompt. Uh, that's it. So now I'm going to run this tool. So when I execute this one, it shows again, it highlighted all the blocks when it is executed, and it shows that it is success. So if you go to detail tab, if you go to start, so you can analyze and debug this, analyze one by one. So you have 4 blocks. So in the start block, not the start block, in the search block, you can find this is the input. So you given the input as this URL as the input, and then the output is like this. This is the text format. I haven't created a better application for you. I am just showing what happens when we create this kind of tool. This is a text input and output. So if you want to use this application as an application with a nice GUI, you can do that. But here I am just showing you how it works. So that's why uh, I have created such a simple application. Okay, in the input, the URL is given and then the output was given like, let me enlarge. Okay, 15 home remedies. So output is given. So that means this is processed. So through the web search, so it could extract these information from that web page. So that is the output. So these are the, here you will see this is the content which was available in my PDF. Okay. That is the output of the Brave search. And then it should uh, go as an input to the large language model. Okay, now it has done properly. If you go through the input, yes, exactly same. That is the input provided for the large language model. And see the output. So this is the output. Okay, this is the output of the large language model. Use the Brave Search tool to search and summarize the search result you received from the context variable. Okay, now the content of the context variable is here. So this is augmented to the um, output of the large language, sorry, input of the large language model, and these information are processed. So this prompt is processed like this. So in the prompt, there was this variable. So in the place where I have specified the variable, this output of the uh, knowledge base was injected, right? So then let's see the output. So this is the output. So large language model generated this output based on the search result. Here is the summary of the current approaches to managing and preventing migration. So home remedies. So this is totally based on the content that I have provided through this URL. So here is the output. So large language model didn't give me a output uh, provided by that large language model. It is, we can clearly um, um, understand that it is, the output is given based on the input, the knowledge that we have provided. Okay. So in this way, in the Diffie tool, you can analyze like this, whether these blocks are executed successfully and how it has been processed, these data. So once you are done with that, you can publish this, or you can uh, uh, extract this part and embed it into a website that you want, right? So yeah, this is a workflow that the previous one is a chat flow. So this can also be created in the same way that I have created the chat flow. So what you have to do is you have to go to Studio and create from blank and create a workflow. Earlier I have chosen chat flow. Now you have to create a workflow. Meta 3, 4 workflow. Okay, I just gave a name to it. Create. Okay. Now you have to add, as I shown you before, Brave node. You have to add like this. And then you have to add large language model from the blocks. You can select a large language model. And then you have to add end node like this. You can connect by clicking on this plus button. Like this, you can connect these nodes. Yeah. So you have these organized blocks. When you click on that, it will nicely arrange. So you just have to add those variables now by clicking on these blocks. Yeah, that's it. Yeah. So if you would like to try this out, and if you have any questions, you can ask from me. And if you want more support, you can talk to Mr. Sanjay or Sampath on DeFi. DeFi, they have servers, so you can talk to them and talk to any of us if you have any problems related to this. But learn about RAG. That was the purpose of my session today. Um, I don't know whether it is something useful for you, but I think that you should learn these type of tools as well, because if you are not going to develop, like there are various ways that we can create apps in the medical context. So it is always better to analyze these type of tools, and if there are tools which are already available, then we can use those tools without reinventing it. Like creating this type of system is not an easy thing, but you can do. There are tools that you can create these type of tools, but if you can use these things and make your um, uh, life easy, then I would suggest to use these type of tools. And also at the same time, even if you want to develop your own tools, you can get a better idea on what's happening in these tools, how they have used these AI concepts in these tools. So that's why I have explained it. You can, if you have questions, you can ask. Uh, Siloshan, I think you can start now.
Sure. Thanks, Maisha.
Thank you, Nayana. Dr. Nayana,
Thank you.
thanks.
Okay. So yeah, okay. So I will share my screen. Okay. So I will start where Maisha ended. Maisha asked during her session, he asked a question that whether this is the platform she showed to you guys are like useful or not, right? Okay, I will start from there, right? So I started a small advertisement actually. So agentic AI. So agentic AI is the most what do you call most trending topic these days, right? So agentic AI is doing a lot of things and started killing. I mean, started pushing people from the pushing out the people from their job, and so knowing how agentic AI is working or how agents are working is very useful these days, right? So I will show one small example before I start my session. This is I saw this message from in my LinkedIn. The CEO of relayapp.com is saying that our marketing team is just me and 40 agents, right? This is how the agents are. These are the agents. Okay. So these are the agents. So this is how the things are going to happen now, right? So if, as I said last time, the most of the tasks are getting now replaced little by the AI agent, because the way agents are working is really, the quality is high, the most of the work can be done very quickly, the cost is very low. So because of that, the agents are getting replaced with the employees. So I think the most of the agentic related things what shared by Maisha are very useful. So I believe if you have a workflow in your medical domain, you can use that to get it done your work. Okay, so that's a small advertisement before I start the lecture. Okay, so today, as I said last time, today the lecture is about the generative adversary network, which is GAN, right? Okay. So before I start talking about GAN, I wanted to explain. Actually, GAN is very it has very relationship between with the image processing, right? There are some text processing as well, but image is the GANs are for the image sort of thing. The GANs are working depending very highly, right? So before I start explain about the technology or the workflow about the GAN, I wanted to recall some of the items what we discussed in the early session. Some might be the new and some might be the things what we need to recall, right? Okay, so I will go to my mm, uh, collab book, right? Okay. So here I have uh, now I am going to do small thing, right? That is, I am going to download one image. I will show that image. This is the image. Uh, this is the image, right? One cat image. I will upload this to my Collabo.
Siloshan,
Yeah,
we can't see the screen. I don't know others whether it can be seen by others.
let me.
Can you all see the screen?
We can
Yeah,
see, but
we
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 can't
can see.
see any cat.
Yeah, we
How
can
It's
about
see
not
the
now?
in
cat.
side mode, no?
Can you see now?
Now I can see. Your
Okay, hold
collab
on.
I can see. Yeah.
Okay, hold on. Okay. Can you see this window as well?
Yes, yes. Now okay.
Okay. Then this cat should be shown. Can you see this now?
Now we can see.
Yes.
Okay, wonderful. Thanks. Okay, thanks for confirming. Okay, so this is the image. Okay, so I have uploaded this image to my Collabo. So I'm going to extract the what do you call the pixels from this image first, right? The reason why I am trying to show you about the the pixel is that as I said in the previous sessions, the image, even though image, if you look at that, the image is a bigger thing, but image is created with some numbers, right? Okay. So if we play with the numbers, then we can create whatever the image, right? Whatever the image. So as an example, let me show. I will create from this cat image. I will reduce that image size to 10 by 10 pixel 1, right? 10 by 10 pixel 1. So now you can see that cat image reduced to 10 by 10 pixel. So you can see 10 pixels here, 10 numbers, which is varying from 0 to 255 and 10 pixel here. So this entire matrix represent this image. This is not look like a what do you call cat because due to the resolution. But when we increase this, I will increase this 50 by 50, 50 by 50. Then you can see the matrix, the number matrix has increased. That means there are 50 pixels here and there are 50 pixels in this way. And the image become bit clear and can visible, right? Compared to the previous one. Then I will resize this to 300 pixel to 300. So now you can see that image is much better because the number of pixel in the height and width is increased. So the pixel, when the pixel count is increased, the quality of the image is getting very better, right? So this is just a recap before we start about the GAN. Just think about, and we with the numbers, with the image matrix, we can do a lot of things, right? Okay, so okay, let me share my okay. So this is what I discussed. The matrix can convert to the images, as well as when we increase the matrix size, we can get a better image, right? Okay. So the next question. Do you know this person? Anyone? Okay. So I will give the answer. There is no real person like this, right? This is created from the use of GAN, right? From the use of GAN. I will show that. If you look at another face, this person does not exist in the world. This person does not exist. This person does not exist, right? But look like very real. The reason the matrix played, or the matrix to the machine learning model created the matrix which is similar to the image matrix of a real person. That's how these images are look like a natural, right? So if we get the eyes, so the pixel of the eyes is very natural and very similar to the pixel which if you extract in the real person. So that's why this is look like a real, right? Okay. And next thing, right? Let's start. What is GAN, right? So when we describe about GAN, there are a couple of things we have to put in our mind, right? First thing is that it is a machine learning model, right? GAN is not a like rocket science, but it's a machine learning model as we learned previously. But this include two neural network. We discuss about what is neural network. If you remember some images, we discuss about some neurons, then how neurons moving. Likewise, we discuss a lot of things about neurons. So this consists of two neural network, right? And the other thing is this can reassemble the input data, right? This can either regenerate or can edit or modify the input data. So when you are talking about GAN, you should mind it. You should know that it's a machine learning model. First thing, it has a two neural network, and it can reassemble the input data, right? Okay. So now, let me it all drawings. Okay. So, see. Okay. So, here we go, right? So, in the GAN, there are two parts, right? As I said earlier, two network is a two part. The first part is the generator, right? I will explain it later. The second part is a discriminator, right? So how this is happening is that, think about like this, right? I will show a small example, right? So think that there is a thief here, right? The person, and think about this is the road, right? This is the road. He has to go to with the item what he thief, and there is a policeman here. So the thing is, when you are, if you are a thief, so when you are going to this road, if police is here, then police will start asking questions, right? So if the police start, if you give the correct answers, you can escape from this, right? You can escape from this simply. But if you are not giving the correct answer, then there is a route to move out, which is there, right? Okay. So this is the same concept applied in the GAN, right? So how can I delete? Okay. So here, these are the, so we have a discriminator, right? Which, think about that, a small component which knows about what we are going to do. As an example, if I need to generate the numbers, think that this person is well know about the numbers. And if I'm going to create the person face, this component is well knowing about the face features, right? That's how discriminator works. Then we have a generator, the other component. This component is always trying to generate something, right? And trying to pass to this discriminator, right? It's a kind of an exam. Like, think about that way. So the person is learning something here. Then there's an exam. He is facing for the exam. If it is got the mark, he can go through this. Otherwise, he have to learn it again. Likewise, in the GAN, the generator always start creating noises, right? Noises. Then go to the discriminator to check whether the noise can accepted by the discriminator, right? Because discriminator is no. As an example, if we train a discriminator to detect the numbers, then generator creates some noises. Then is checked with the discriminator whether, based on the trains he has done with the live data against to live data, whether this one is correct or not. If it is correct, then it is pass. If it is not correct, then it will not pass, right? This is how, in a simple way, how GAN is working, right? I believe you get some good understanding. So there are a couple of points that there are two neural networks. We are calling that as a generator and discriminator. So then through that, generator will always create the noises and learn from the discriminator, and then give the better, and then generate better noises based on the rejections. Then it's try to pass the data to the discriminator, right? Okay, so let me delete drawings. Okay, so I will show a simple example. Okay, so maybe to here. Okay. So I have created a small, actually, the GAN, to create a GAN model using the some of our available resources is very difficult, because we need a lot of GPU power to train the data. Then even though we able to train the data, we cannot show the live demo within this 1 hour or 40 minutes time. So I have already created one model. I will explain it. I have created a 2D model. What I'm going to do is, let me first explain it, right? Okay, so what I'm going to do is, think that I have a sum of the data point in the, think about this is the place where the data point is located, right? These are the real data, right? Real data. Then I'm going to create one or couple of new data which is going to match with these features, right? So initially I don't know what are the features are here because I have not run through my data to the discriminator to check whether it's correct or not. This is the discriminator. Think about that. This is the data which discriminator knows, right? Okay. So I'm creating one of the data here, right? This is not related to this one. Then I try to move this data or run this data to the discriminator to get a better understanding, right? And based on the learnings, then I will create another data. Likewise, I will try to move to inside this or the place my data or the generate the data compare. I mean similar to this the discriminator data, right? Okay, so let me show that. Okay, so I have created a simple a training loop to train my discriminator here, right? I'm not going to, you don't even, no need to understand about this code as I said earlier, but I'm just telling what I have done when I'm showing this example. So this is the train generator. So there are two component here. Now what I'm going to do, I have created, this is my first attempt to create. The blue colors are the real one. The red colors are the fake one. What I'm trying to generate the data which match to this feature, right? So first I have generated during the first step. When I check with the discriminator says that the data I have is located in this place, but the data you have generated is in this place. So you cannot pass it, or I cannot pass your data. Then I'm going to the next one. Then I generate again because I got some understanding about how this is happening and how this is located. Now I have generated some fake data which is bit near to the real ones, right? This is the after 50 steps. Then again, based on the understanding, then again this is rejected. Based on understand, I try to create another set of data, right? It is bit far away compared to the real data. That may happen when we do some trainings. So even you learn, you are trying to new things, but sometimes the trying new things create a reduced distance. But for some cases, if you are trying new things, but it will create some it will create increase the gap between the real positions, right? Okay, so now after 150 sets, the generator able to create some data within the data which is placed in the real area, right? So after that, even though we run the couple of steps, you can see that the data is within the place. But there might be some cases, if we run the more steps, maybe this data again going to out of the area. So we have to make sure that once it is started generate the data according or match to the generate discriminator, the data if past the discriminator, so we have to stop our training. So you can see the after, so I have run couple of more steps. So you can see that again the data is going out because it's when I still running, it still think that the data is not up to the expected level, right? Okay. So, okay, you can see I have a lot of training. Okay, so this is how in a 2D way, how the noise is generating and how the discriminator is passing the data. Okay. So okay, so the same thing, the generator gets better at faking, then discriminator gets better at detecting, right? So the both is happening. So discriminator getting trained based on how the generator is faking. So generator is getting better at faking, so that he can easily bypass the discriminator, right? Okay. So okay. So, and I will show one more example how image generation is maybe I have, okay, so this how image generation is okay. So this is the initial state, right? So in this example, the discriminator trained to catch the real faces, right? Now the generator is starting to start creating noises to try bypass or try pass through the discriminator uh, rules, right? Okay, so this is the first attempt. So you can see the images. This is the generator has created around how many? Around 20 images, I guess. 20 to 24 images. First atom is not so good, right? So see the next atom. It's look little bit similar to the faces, right? But still there is a gap. So discriminator is still rejecting because discriminator knows that how the face should look like, right? So I will go another couple of steps. So now you can see the generator generating, getting better and better. He's like the generator is getting educated based on the discriminator. Now you can see the noises or the pixel the generating by the generator is better than the previous step, right? Now you can see when we start compared to the starting level, the the generator learn lot how the face features he can pass to the discriminator. So okay, so now you can see still running, still learning, still learning. You can see how the generator is learning to generate the images. Okay, so this is the last step. So you can, if you have a GPU power, you can train a lot of time and lot of hours with a lot of GPU power. But in this example, it's trained till some maybe 1,000, 2,000, 5,000 imports, not more than that. But this is the level the training has stopped. But this is the level that generator able to generate the face images. But we can still see some issues, but it is better than the how it's started, right? So okay, so and okay, so in the theoretical part, we can this generative modeling we can uh, we can do to the supervised data, as well as we can use the unsupervised data to get train the generator and create the what do you call the generated images. So I will okay. So now this is where you can see the GANs, right? So I know that you have you have explained, or you have went to a lot of websites and a lot of AI related stuff. I know that you have created some lot of images as well, but these are the fields, or these are the topic usually uh, GAN is supporting to do the work, right? Okay, so first thing is the noise input, right? Either adding the noise input or denoising, right? So as an example, so if you get a CT or maybe the MRI scanner, you can use the GAN to reduce the noises, right? So as an example, so this is one of example, the denoising used to the scan images. You can see this photo has some noises which create the extractions issues, like you can see the name, maybe some other details you cannot get the correctly due to the noises, right? But here you can see the use of the GAN, the noises have been removed and the quality is much better. The scan quality is much better than this one, right? See this image. This is also another example, as I explained previously. And see this, a document which has some issues when the take the maybe the this is a kind of a photo of the document. So it has some lightings, the lighting, due to that lighting there, it's covering some text part as well. But when it's come to the denoised image, you can see the good improvement. This is the one area where the GAN is using. The other area is that simulated data, right? So as an example, uh, synthetic patient record generation. This is one of the use case which may be using the one patient record. The GAN can simulate multiple records with the same. Might be maybe that you can find in the we compare to the actual data, that may be the correct one, or that might be the wrong one, but it can create some lot of synthetic data, right? Okay, so I guess this Medigan we discuss, or maybe Maisha also discuss about how Medigan is working, as I remember, I'm not sure. Here you can see based on the input, it's Medgan generate some simulated, or the enhance and the scan images to get a better understanding and understanding. So the input enhance to the GAN to get a better understanding, right here. So this is another use case. And this one is the prediction of the future state. Maybe this is kind of having two more in the maybe the head of the place, then maybe this may be the third subject or maybe the third phase. Then it's predict how it's going to grow in the sixth stage, right? Okay. So for this kind of work, we can use the GAN so that we can get the treatment earlier before it's growth. So because we can get an understanding how it's going to grow. Maybe compared to the previous couple of stage, we can predict how it is going to happen in the next coming stages, right? Okay. So also it's helped to generate the missing data. Okay, so the same thing, I guess. Okay. So now, since we have only 15 minutes, let's talk about what are the type of GAN we have. So there are basically there are mm, 4 type of GAN, right? So the basic GAN is the one I have explained how it is happening. Then we have DC GAN, then we have the conditional GAN, then we have the info GAN, right? So out of these 4, this conditional GAN is very famous nowadays, right? I will explain about that later. Let's go one by one. This DC GAN. Okay. So this DC GAN has some convolutional network, specially designed for the image generation process, right? So you know that CNN, I have explained about what is CNN. The CNN is that it has some multiple layers embedded to the, what do you call, embedded to the neural network, on top of the neural network, so that once we have the image, it creates some based on the pattern and based on the pixel features. It's helped to improve, or the helps to maybe helps to understand the features, right? So I explained a lot of things about the CNN in the previous lecture. So this DC GAN has 2 CNN network. It's helped so to create the images, to generate the noises, and the check the noises are correct or no is easily, because I have explained why the CNN become to the picture. First, in the lecture, I have explained what is neural network. Then I have explained what is the convolutional neural network. So compared to the neural network versus convolutional network is the better one, which help for the image sort of processing, right? Okay. So for the DC GAN, it has 2 convolutional neural network attached to the generator and discriminator, which help and which create fast and quality generation, as well as for the detection, right? And the famous one is the conditional GAN, right? Why I am telling this is the famous one. This conditional GAN can combine with the text, right? As an example. Okay, so as an example, here, think about that. We have here the generator, right? Generator. Then we will have a discriminator here, right? Which is checking the generated image, right? So in the conditional GAN, we can give a text input as well, right? Text input as well, so that when this generate, it will not generate the random noises based on the generate understanding, but when he generate the noises based on the, to align the text as well, right? Text is given. So it's combined with the text and then it generate the noises, then it will try to pass to the discriminator. So when I tell about this workflow, you can imagine that the use of the conditional GAN. So I know that you can you have created a lot of images from the sites. So the most of the sites which build to generate this image to the text is powered by this conditional GAN, right? So it's one of the famous these days. Then let's go to quickly the rest of. Okay. So so let's see some challenges with the GAN, right? Okay. So when we train this GAN, we have a lot of challenges because the GAN, this training process is for some cases unstable, right? Because the noises which is generating to the generator, controlling that is kind of a difficult, right? Because it's generate its own. There are some sort of the techniques we can see nowadays, but in the generally it's unstable, right? And can lead to non-convergence, and it creates some complex situations, and it requires a careful hyperparameters tuning to get a good output, which create maybe which needs some lot of cost involvement and lot of knowledge. So those are some major challenges we can talk about the GAN, right? And few of points I am skipping because I am discussing only the important thing with the interest of the time. Okay. So then here I have added couple of points. Some problems, some common problems of the gas, right? The major problem is that the issues of the output, right? So anyway, the output quality might be good if we are using the GAN, but the controlling the quality of the output is kind of difficult when we build a GAN, because think that, so in our workflow, the GAN, we train a discriminator to check the generator's work, right? So anyway, discriminator is a trained one, right? It's not a real one. It's a trained one. So it has some accuracy, right? It has some accuracy. So generator, generator's task is, however, the pass the data to discriminator. Maybe a good way or maybe a bad way. To a good way or to a bad way, right? So if we have not trained the discriminator with the quality data and with the quality accuracy, I mean the highest accuracy, then the data which is then the generator will try to go to pass the incorrect data as well, because maybe let's think about then the discriminator has a 99 accuracy to pass data. So still we have 1% chance to generate the incorrect output, right? Because this is not 100%. Discriminator will not come 100%, right? So in this case, we have to this is a common problem, right? In the all the GANs. We have to improve the discriminator quality to get a better generated output. So and to improve the quality, as I said, so we need some better training process to conduct and parameter training. Then we need some centralized normalization process to get a better output. I mean, the everything will depend on the discriminator's knowledge, right? So whatever the thing we are going to do to discriminate to train the better output, then the generator can't fake uh, the discriminator, so that we will get the better output, right? And okay, so and also I have put some technical mm, points how we can improve the gas. So if any of you like wanted to uh, create again and do the improvement, you can go to this step. So I will not going to explain further, but those are some kind of a technical method. So we have some ways of data augmentation, and we can assemble the discriminator, and we can do some transfer learning, and there are a lot of ways we have to improve the discriminator knowledge, so that we can generate the better output. So and here uh, so when you are working with some website with the GAN powered, so you can see some let's say there are some examples. You can see that you are uploading your face, and then you are generating your face when you are how it look like when you're at the 80s or 90s, right? So for that as well, we use the GAN. It has uh, regression ways, right? Regression ways. It's using the method called regression to generate uh, the face to look like the either older one or either younger one. Uh, and for the future of the GAN, it is very uh, maybe what I'm thinking is that GAN will be play in the future the biggest role, right? It will play the biggest role, right? The reason is GAN, we can use GAN for the most of the uh, uh, thing, or if we use the GAN for the correct way, it will become good quality output, or it will help to improve the day-to-day activities. But if we use the GAN in the incorrect way, so that it will create a lot of trouble in all of the life, right? Okay. So the thing is now, are GANs safe, right? So I'm not answering the direct answer. Yes, for some cases, GAN is safe for all of us. For some cases, GAN is very dangerous, right? Because uh, if you remember, uh, the deep fake is one of the product came with the GAN, support of the GAN. Probably you have heard about. I remember I have put that. Okay, so deep fake example. Let me show one example. I'm not sure. Okay.
Second youngest son. He's
So can you hear the voice of this? I'm not sure.
suggesting it came out of nowhere. What we subsequently learned is it may have come from the former
Okay, anyway,
president
no
or
worries.
his legal team
So
acting in bad
here
faith.
you can
This is a
see
deep fake example of what is
original image, right?
powerful computer and editing.
So this
It took
is the
around
deep fake
72 hours
image
to create this example
created
from scratch
with the
using
use of
extremely powerful GPU.
the GAN, right?
It could be improved with more computing
So,
time, but 90%.
If you look at the both videos, the first video is the original one. The second video is the fake one. But the content, the original one represents maybe a news about his company or something. But the second one is completely presenting a completely incorrect thing, right? So, as I said that, so if you use the deepfake to improve something, that's a good thing. But if someone is using to create some fake thing, then it will gonna bigger trouble, right? Okay. So let's quickly finish. We have so we have almost running out of time. Okay. So couple of advantages. We can fast generation, then we have the realistic output, flexible application we can generate. And so I will go to this quick. Okay, so again another question. Do you know this person? Anyone heard about this person? Okay, so he's the person who introduced or who released the first paper about the GAN, right? Probably we think that he did a good job if the GAN not people if not used for the wrong thing, right? So because of that, we call this person Goodfellow as a father of GAN, right? Okay. So, and I have put example here how there are a lot of papers are releasing from the GAN side, because there are a lot of the generation is needed, generation must, right? Because so as an example, if we need to record a video, we need to hire actors and all of the stuff, right? But if the GAN improved to generate, we can see now the videos are generating based on the GAN. But when it's compared to the original one, we can see some of the differences, right? If you look at in the previous video, you can see some differences. But with the time, you can see that you will see that the the generated things are getting better and better than the previous one. So because of that, the reason is that there are a number of papers and number of researchers are going on about the GAN, and you can see the exponential growth of the papers which is releasing base for the GAN, right? Okay, so yeah, I guess that's all for today. Yeah, okay, yeah, that's all for today. So okay, so I have showed this. Okay, so I believe that all of you have get a better understanding about the GAN, how the GAN is working, and what what's sort of the thing you can and how the GAN is prepared and how the workflow is defined. So I guess you get a better understanding, but if you still have a question, maybe we have a time to answer the questions, or otherwise we can adjourn for today. Okay, so thanks everyone then. Let's meet in 1 week time, maybe next
Thank you.
Saturday. Okay, thanks
Thank
everyone.
you. Thank you very
Thank you.
much. Good night. Good
Yeah.
night.
Right.